So now let's try to independently take into account how the energies that are needed to form a sodium positive ion and a chlorine negative ion. So here we have a neutral sodium ion. So in order for it to form Na plus and 1 electron, you need an input of 5.1 electron volts. Now in the case of a neutral chlorine atom, for it to form for it to combine with a free electron and form a negative chlorine ion, you need to input minus 3.1 electron volts. So in other words, if you want independently, take note that this is independent reactions, to get Na and Cl ion, you need, let's calculate, 5.1 electron volts plus minus 3.1 electron volts. You need 1.5 electron volts. So these two atoms are isolated. They are not to bond to form a ionic bond yet. So take note of this number, 1.5 electron volts. Now, if we imagine that these two charged ions interact with one another to form an NaCl molecule, so you want to form a NaCl molecule. The NaCl molecule now will have a potential energy of this form. Okay, so let's try to look at what this potential energy curve for the NaCl molecule mean. For what this potential energy curve for the NaCl molecule mean. So it has a minimum value of minus 4.2 electron volts. So what this means is that one of these species in this chemical bond is bounded to the other by means of this negative potential. So for example, you have your chlorine species here, and you try to move NaCl. For the sake of having a diagram, you try to take a nudge of R here or R here. You try to tweak their atomic separations. So what happens is that this chlorine species, as it moves at greater values of R, it becomes less bounded to the sodium atom, until to a point that it has zero potential energy. It is now free to it has zero potential energy. It is now not bounded to the sodium atom. So what happens now, if you move in closer to this potential energy curve, R decreases, and it sort of like approaches a value that becomes repulsive to sodium. So hence, chlorine atom sits at this minimum value of minus 4.2 electron volts. So this means that this is the most stable situation that this molecule will form, and this is also called the binding energy of sodium and chlorine. So if we look back in our independently formed ions, what happens is that this electron given off by sodium is it became the electron that is accepted by chlorine. So in doing so, they are able to bind with only having minus 4.2 electron volts. So if you would compare 1.5 electron volts in the independent case, so you have here sodium cation and chlorine anion versus this minus 4.2 electron volts on, say, let's call it the ionic bond. So in the case that they form a ionic bond, NaCl, this minus 4.2 electron volts is way more likely to happen because this is energetically more favorable. So what this means is that in nature you won't be seeing much of this event happening. Sodium cation and chlorine anion independently being formed, and you are more likely to see sodium chlorine molecules. So you are more likely to form a salt than independently forming sodium and chlorine ions. So this is how ionic bonds are formed. Ionic bonds are formed simply because it is energetically more favorable.